Alright, welcome back to the pcyse channel. Today I'm going to talk about Python computations for science and engineering labs. This is a continuation of the Introduction to pcyse and Intermediate pcyse booklets that I talked about before, and this one is really intended for people that work in labs or that are taking laboratory courses, and in particular it is like the introductory or first lab course. So what's different about labs is usually you have other things you have to do. It's not just solving an equation or integrating a differential equation. We usually have to do things like read data files. And that may be measurements that you've made and stored in the cloud or in Excel or in a text file. And somebody's measuring them over here and somebody's analyzing that data over here. So we talk a lot about how to read Excel files, how to read text files, even how to read Google Sheets and things like that. Then you need to visualize your data. So we have a chapter here. You can see on this side line plots, error bars, subplots, shared axes. Your basic figures for visualizing the data and looking at how these things work and how to put different kinds of error bars and things like that. Then we also have to do things like statistical analysis. So we might need to know the average or the spread, or as somebody may want to know about confidence intervals, whether two data sets are different. And all of that's possible in SciPy with the statistics modules, looking at whether things are different, uncertainty propagation, and even uncertainty propagation with units. Significant figures are something that is important to use the right number of them, and Python can help you with that as well. So you can specify how many sig figs you want, or you can use it with uncertainties. Then there are fitting data, and we have all kinds of things we might need to fit. You can fit polynomials, you can do linear regression or nonlinear regression, and in any case you need to have uncertainty quantification. That is, how good are the parameters that you estimate from them. And pcyse supports that in a nice way, so we can easily find out how you can fit even a polynomial with uncertainty parameters. So here's some examples where we can get a fit, and you can see the standard error, and you can work out what the confidence intervals are, and then show what the fit looks like that. Okay, so it's easy to get the uncertainty of the parameters and get good plus or minus values. And that works in polynomial fitting. It works in linear regression, where we have linear models that polynomials are just a special case of. It works in nonlinear regression, where you can see how to fit different things and get to uncertainty quantification through nlinfit. And finally, we talk about outlier detection, where you might want to be able to detect if something is an outlier or not, and some discussion about goodness of fit. So that is, in a nutshell, the introduction to pcyse for labs, and you can find this booklet in the link in the video description. Please share this with anybody you think would be interested in it, and if you like the video, please subscribe and hit the like button. All right, thanks.